Hello students, today in this video from the chapter magnetism, we are going to study about the topic magnetic dipole and magnetic dipole moment. So previously, as we have studied in electrostatics, the fundamental or simplest structure that can exist is a point charge. Okay, so the very simple structure that can exist in electrostatics was point charge, and when we have two equal and opposite charges separated by a small distance, they form an electric dipole, and to describe that dipole we have used electric dipole moment represented by p vector. Now in magnetism, the isolated magnetic poles doesn't exist. These magnetic poles always exist in the dipole. Okay, so the simplest structure that can exist is the magnetic dipole, and which is described by using magnetic dipole moment. So in magnetism, the simplest structure that can exist is a magnetic dipole, and it can be defined as the arrangement of two equal and opposite magnetic poles separated by a small distance. As electric dipole was defined as the arrangement of two equal and opposite charges separated by a small distance. Now here in magnetism, magnetic dipole can be defined as an arrangement of two equal and opposite magnetic poles separated by a small distance. This is called a magnetic dipole. As magnetic monopole never exists, so there is always a magnetic dipole. The simplest structure that exists in magnetism is magnetic dipole. If we want to know the example, so every bar magnet is a magnetic dipole because it contains one north and one south pole. A current carrying loop also behaves as a magnetic dipole. If you see the example, so a bar magnet is a magnetic dipole. A current carrying loop also behaves as a magnetic dipole. Even if we have an atom, it also acts as a magnetic dipole because of the circulatory motion of electrons around its nucleus. So if we have an atom, it has a nucleus and electrons are revolving around it, so it also forms a magnetic dipole. Now to describe this magnetic dipole, we need magnetic dipole moment. Okay, this magnetic dipole, this magnetic dipole is described with the help of magnetic dipole moment, and we represent it by m vector. Okay, now let's see what is magnetic dipole moment. So magnetic dipole moment can be defined as the product of the pole strength and magnetic length. Magnetic dipole moment for a magnetic dipole is defined as the product of its pole strength and magnetic length. So we can write magnetic dipole moment as magnetic dipole moment can be defined as the product of its pole strength and the distance or the magnetic length, the distance between the poles or the magnetic length. This is the magnetic dipole moment. It is represented by small m vector, and mathematically it is given as m vector is equal to qm into 2l vector. Now m vector is the magnetic dipole. It is a vector quantity, and and its direction is always from south pole to north pole. Okay, direction from south to north pole. This is the direction of magnetic dipole moment, and it is given as m vector is equal to qm into 2l vector, where qm is equal to the pole strength and 2l vector is equal to magnetic length in the direction south to north. Okay, 2l vector is the magnetic length, and in the direction, we always take magnetic length in the direction south to north pole. Alright, so m vector is equal to qm into 2l vector, where qm is the pole strength and 2l vector is the magnetic length of the dipole measured in the direction south to north pole. If we talk about its SI units, then from the relation, its SI units are, the SI unit of magnetic dipole moment is, so here we have charge into length. Okay, charge into length, then its SI unit will be, now the SI unit is joule per Tesla, or we can write it as JT inverse. Okay, so this was the magnetic dipole and magnetic dipole moment. Magnetic dipole is the arrangement of two equal and opposite magnetic poles separated by a small distance, and it is described with the help of magnetic dipole moment, which is defined as the product of its pole strength and magnetic length. Okay, so this is the magnetic dipole and magnetic dipole moment. That's all for this video. Thank you. Keep studying and stay tuned.